Today we're going to talk about comparing populations, and we're going to use a double box plot, which is the box and whisker plot that we did the other day to compare two populations. And we're going to briefly look at a double dot plot as well to compare two different populations. Before we begin, I do want to real quick go over all the main points of a box and whisker plot again, just to review with you guys. So on here, we would have a minimum. And again, the minimum is going to be the least value in a data set. So for here, for example, the minimum would be at 10. The maximum, as I move everything there, the maximum would be the greatest value in a data set. So in this one, the greatest value is going to be over here at 50. So the minimum and maximum are going to be where the dots are. Next, if I have the range, obviously the range is the difference between the greatest and least value in a data set. So if I look at that, my minimum was 10, my maximum was 50, so my range between my 2 points would be 40. The median, remember I don't have that one listed, but the median is going to be the line that's inside my box, so 35 would be the median. The first or the lower quartile, that's going to be the median of the data values less than the median. So my first quartile is over here at 25, and my third quartile is the median of the data values that are greater than the median. So if I look at that, that would be over here at 45. My inner quartile range, and that's going to come up a lot in today's video, is the distance between the first and third quartile. So I wouldn't find the range of the whole data, I would just be finding the range of the box. So between 25 and 45, between my first quartile and my third quartile, my range between here would be 20. So what we're going to be doing to compare it is a double box plot is going to have two box plots that are going to be graphed on the same number line. A double dot plot is going to consist of two dot plots that are drawn on the same number line. We're going to be drawing inferences about the two dot populations by comparing their centers and their variations. So what we're going to be doing, and this is going to be an important slide that you might want to screenshot or even just refer back to in the video a little bit, but if both my sets of data are symmetric, I'm going to be using the mean and something called the mean absolute deviation. Okay, if I have one is symmetric or neither is symmetric, meaning that I have somewhere I have something that's non-symmetric, I'm going to use the median and the inner quartile range. Again, this is going to be a very important chart for what we're working on today. So when I look at this on here, I want to look and see these two different box plots I have of the number of blog posts in a month for math class versus a science class. So I have two box plots on the same number line. I have my top one and my bottom one, and they're both going to match up with the same numbers going down the bottom. So I need to first determine, are they symmetric or are they not symmetric? So I look at this here, symmetric means that the left side is exactly like the right side. So I'm going to go to the median, I'm going to look and see, okay, on my left side of the graph, does it look like the right side of the graph? I can see that from the median to the left and the median to the right is way longer, so I can tell math class is not symmetric. If I look at my science class, well, it looks like my box part is symmetric from the left and the right, but my whiskers are not symmetric. But symmetric means that they're mirror images. So if I look at the median, is the left side exactly like the right side? No, they are not. So going back to my chart, both sets are not symmetric. So if neither set is symmetric, I'm going to look at the median and the inner quartile range. And I'm doing that because these were not symmetric. So I'm going to be looking at the median and the inner quartile range here. So if I look at my median for math, well, median is going to be right here in the middle. So my median for math would be at 10. Why I put a number 1 there for it, but we'll just ignore that. The inner quartile range is going to go from 5 to 20 because I'm going to look at how far apart the box is. So my size of my box is 15 for that. And ignore the number 1 in front. I don't know why it's typing that. Now if I look over here for science, my median for science, well, I'm going to look in the middle of the box, so I'd be at 20. And if I look at my inner quartile range, it's going to go from 15 to 25. So my inner quartile range would be 10. Now I've kind of examined that, I can make some comparisons between the two. If you look here, it looks like in general, science class has raised more money. Yes, they both have the same minimum and maximum, but you can tell because the box is up higher, I would say, not raise more money, the science class has posted more times this past month. Looks like science class has that. And they also look a little bit more consistent because their box is closer together, whereas math class is a little bit more stretched out, which means there's probably more variation. What the book had wanted you to come up with, and again, would not expect you to write all of this, but the book is saying overall science students posted more blogs than the math students. That I think is important to recognize. That when you look at this, you can see science looks like it's done more. The median for the science class is twice the median for the math class. I think we could tell that yes, the median for science is higher. And again, there is greater spread of data around the median for the math class. So we can tell math is a little bit more spread out. All right, we're going to look at this one now. I'm going to have you guys kind of work through this and answer some questions about this one. So this is how many people go ziplining at these two different companies. We have Treetop Tours on top and Zip Adventures on the bottom. So my first question for you is about, are the box plots symmetric or not? Okay, I hope you guys recognize that when I look at this, Treetop Tours is not symmetric because again, the box you could tell is not symmetrical and neither are the whiskers, but Zip Adventures is. You should have picked that. Only one of the sets is symmetric. So if I go back here to this one, if only one set is symmetric, then I would use the median and interquartile range again. So when I look at this, if I want to find the median and the interquartile range, you guys are going to be answering all of these questions for me here, but I'm going to do Treetop Tours, you'll do Zip Adventures. So look at Treetop Tours. Treetop Tours, its median would be the line inside the box, which matches up with 70 on my number line. So that would be 70. The interquartile range is going to be the difference between the left side of the box, my first quartile, and the right side of my box, my third quartile. So I would have 80 minus 50. I'll even type that in there so you guys remember what I'm doing. 80 minus 50, which would equal 30. Okay, you right now are going to be telling me what is the median for Zip Adventure. So I look at this bottom box plot right here on the bottom. What would be the median? Okay, the median would be the one that's right inside the box. So hopefully you guys figured out the Zip Adventures median would be 50. What would the interquartile range be for Zip Adventures? Okay, so to find the interquartile range, I would take my upper quartile of 60 and subtract my lower quartile of 40 to get an interquartile range of 20. Some comparisons you can make when you look at these. Okay, when I look at this, I hope you guys could tell that Treetop Tours looks like they have a greater number of daily participants. Okay, however, they have a bigger range because their minimum and maximum are way bigger and their range of their whole data. They are much less consistent with how many people they get. Zip Adventures, although they get less people on a daily basis, they can predict more likely, like, okay, we're probably going to get about 50 people. Whereas Treetop Tours, it's going to range a lot more and it's going to be a lot harder for them to know how many customers they're going to get in a day. So again, Treetop Tours is a greater number, however, they have a greater variation, so it's more difficult to predict. Zip Adventures has a greater consistency. Okay, the next thing I want to look at, I just want to quickly look at a dot plot. You guys have not really seen dot plots that much, however, dot plots are just going to have a dot or sometimes it's an X to show the different points of data. So if I look at this one on here, this dot right here on the graph, this represents one temperature of 81. This is 2 temperatures of 82. This is 4 temperatures with 84 and so on. So when they go to graph the data, instead of making like a bar, they just put a dot and then that each dot represents 1. And then you don't need the y-axis with all the numbers on it. So look at this on here. If I look this, if you notice, I have 1, 2, and then a 3. And then I have a 1, a 2, and a 3. So if you look at this, if I were to fold this graph in half, right along my tallest point right here, the left and right side match perfectly. So this Springfield one is symmetric. Down here, if I look around again in the middle, my left and my right are exactly the same, so they're both symmetric. If I were to refer back to my chart, since they are both symmetric, I'm going to use the mean and the mean absolute deviation in this graph. So these are symmetric. So since they are symmetric, and I'm not going to use the median and interquartile range this time, I'm instead going to use the mean and mean absolute deviation. Now, for purposes and time of the video, we are not going to go through all the stuff with the mean, but as we know for the mean, I would add together all the data sets and I would divide by how many points I had. So I would go through and I'd add 81 plus 82 plus 82 plus 83 plus 83 plus 84, 84, 84, 85, 85, 86, 86, and 87. Okay, so I would just add all of those up together, and then I would divide by how many dots there were. I would do the same thing for Springfield and for Lake City. Now, mean absolute deviation, we're going to kind of just skip over, unfortunately, without being in class. It's kind of just something we're not going to focus on as much. But to find the absolute mean deviation, for those of you who were interested, you would find the absolute values of the differences between each value and the mean. Then you would find the averages of those differences. Kind of a little too complicated to get through when we're doing e-learning, so we're not going to really concern ourselves with that too much. However, we can look at these graphs, and even though we haven't calculated like the mean or the absolute mean deviation, we can look that they have the same spread, because if you notice, they go 1, 2, 3, 4, 5, 6, 7 apart. 1, 2, 3, 4, 5, 6, 7. So they both have the same spread of data. However, if we did do the calculations, Lake City would have the greater average, which I think you could kind of look at just by seeing the graph. So again, what's going to be most important is that you know if you are going to be using the mean or median or the absolute mean deviation or the interquartile range. I'm expecting that you guys would be able to locate a median and interquartile range on graphs as well. If we were looking at this, if we had to find the median on a dot plot real quick, so like here, for example, these ones, you can tell this is symmetric, this is not symmetric. So if I wanted to find the median, I could just actually go through and cross out the lowest dot and the highest dot, the lowest dot and the highest dot, the lowest dot and the highest dot, the lowest dot and the highest dot. And then 8 here would be my median. So if I had to find median of a dot plot, that's what I would do.